Hey guys, my name is Trevor Sullivan. I'm a solutions architect with Stratus Grid, and welcome back to our video channel. Thanks so much for joining us for another video. And what we're going to be focusing on in this particular video is how to implement Retrieval Augmented Generation, or RAG, using large language models inside of the managed Amazon Bedrock service. Now, if you're brand new to Amazon Bedrock, essentially what Bedrock is it's a managed service that allows you to interact with as well as customize the behavior of large language models, such as the Claude AI model from Anthropic. You can also use Amazon Titan, which is Amazon's own model that they've implemented. There's also other models like the Jurassic model, the Cohere model. There's a whole bunch of different models available, but we're going to be talking specifically about how to actually incorporate custom documents that you may have in your company's internal knowledge base. They could be notes that you take from meetings, they could be PDF files, they could be markdown or just plain text files or anything of that nature. And you want to be able to interact with those documents. You want to be able to ask questions and get very specific answers from those documents. And this is known as Retrieval Augmented Generation, which is implemented in the Amazon Bedrock managed service as a feature called knowledge bases. So essentially what we can do is upload our content that we have, whether they're PDFs or plain text files and things of that nature, up into Amazon S3 buckets, and then we can actually configure Amazon Bedrock to point to those S3 buckets as knowledge bases so that it can ingest that data, it can convert that data into vector embeddings or chunks of data that are stored inside of a vector database. And then we can actually interact with those documents by simply querying them in a natural language approach, or natural language processing, or NLP for short, where we just use a plain English question, and then the large language model is able to go out, retrieve that information that's been vectorized in the vector database, and then give us an intelligent answer. And it actually links back to the source where it was able to retrieve that data from as well. So it's a really interesting feature. But really quick, before we actually get into talking about Amazon Bedrock, I wanted to briefly introduce Stratus Grid if you're unfamiliar with our company. So Stratus Grid is an AWS Premier Consulting partner, and we're also an independent software vendor, or ISV. We have a tool called Stratosphere that helps enterprises and private equity firms to perform cost optimization across their entire portfolio of AWS accounts. And so if you're an organization that's spending, hundreds of thousands of dollars monthly or millions of dollars monthly, and you're looking for ways to cost optimize, Stratosphere is an excellent tool that will help kind of surface those cost findings that you can go implement or take action on in order to reduce your spend. So if you're interested in seeing a demo of Stratosphere, just go out to our website at stratusgrid.com, go to the Stratosphere dropdown right here and just click on book a demo. And then we can go ahead and get in touch with you to give you a demo of Stratosphere and help you run a proof of concept in your own environment so that you can start realizing cost findings today. Also, if you're interested in consulting projects, feel free to just hit the Let's Talk button up here. We'd love to help you out with a variety of different AWS projects around things like infrastructure as code or computer vision, or lots of other types of kind of net new workloads on AWS that you're looking at potentially building or re-architecting or modernizing, that kind of thing. So feel free to check out our solutions here. We would love to chat with you about your project and figure out how we can work with you. All right, so let's move on to today's topic, which is Amazon Bedrock. And before we actually get into Bedrock itself, I wanted to kind of show you conceptually how these different pieces fit together so that when you're actually implementing things inside of the AWS Management Console and when you're reading through the AWS documentation for the Bedrock service, it'll actually mentally make sense to you in kind of a visual approach here, right? So for starters, we want to interact with our documents, right? So our company has a bunch of documents here that we want to be able to interact with using a natural language approach. So these could be PDF files, they could be plain text files, it could be HTML files, anything of that nature. And we want to be able to ask these questions about those files and then get very specific or pointed responses to the questions that we have. Like, hey, what are my company holidays, right, in the United States? What are the company holidays that are recognized in Colombia? What are the company holidays that are recognized in Ireland? Or I could ask questions about my benefits package, like, hey, how many different benefits plans are available for health insurance? How many options do I have? What are the deductibles for those different healthcare options that I have available through my employer and things of that nature, right? Or imagine that you're maybe a car dealership, right? And you work in sales at a car dealership and you want to be able to ask questions about the different vehicles that you have in your lot. Maybe you sell, Ford F-150s, you sell Ford Explorers, you sell Ford Tauruses and other types of sedans, right? So I've got all these different cars that have all sorts of different features, different engines, different, base features, different premium features. And I want to be able to kind of look into the owner's manual that's hundreds and hundreds of pages long for all these different vehicle models and ask questions like, hey, does this vehicle support stop sign recognition? Does this vehicle support kind of a distance indication from the vehicle that's in front of or behind me? So I can ask questions of those PDF owner's manuals for vehicle documents or vehicle owner's manuals that help me to answer questions about what features are available or how do I activate a particular feature on a particular vehicle if as a car salesman, I'm trying to demonstrate a particular feature to a customer, but I'm not quite sure how to get to that feature. I could ask a document a question. How do I access this particular feature on the navigation in the car? And it'll tell me exactly how to accomplish that using retrieval augmented generation. So those are just some different use cases you want to think about as you're considering whether or not you want to use Bedrock knowledge bases here. All right, so the first thing that we're going to do with our documents here in order to make a knowledge base in Amazon Bedrock is to upload those supported documents into Amazon S3 object storage. S3 is one of the oldest services in AWS, if not the oldest service in AWS, and S3 is basically just file storage, right? You can just create a bucket and you can immediately start uploading files into that bucket. And lots of services in AWS outside of S3 actually depend on S3, including Bedrock, for long-term storage, right? And so what we want to do in order to use Bedrock knowledge bases is to take all of our company source files here, make sure we export them in one of the supported formats, and then simply push that data up into Amazon S3. And you can do that using the AWS Management Console. There's lots of third-party tools available. Some are open source, some are commercial. One popular tool that's cross-platform is called CyberDuck. That's just a graphical tool that you can use to upload data into S3. You could also use the AWS SDKs like the AWS CLI, the AWS PowerShell module, the Python SDK for AWS, the Rust SDK for AWS. It's really up to you as far as how you want to get that data up into S3. There's also an open source tool out there called Tag Spaces. Let me just open up a new search here and search for tag spaces. This is an open source tool that you can use to upload data into Amazon S3 object storage as well. So feel free to check out tag spaces as an alternative. It's just a graphical tool that allows you to work with object storage. All right, so what types of files are supported? We've mentioned things like PDF, Markdown files, and things of that nature. So if we take a look at the supported files, this is from the documentation for AWS right here. So we support plain text files, it supports Markdown, HTML files, Word doc files as well for Microsoft Word, CSV files, XLS files, which are like Microsoft Excel files, and then also PDF files, which is a very common industry-wide standard format for documents. So those are the different file formats that are supported by Bedrock knowledge bases. The next thing that we're going to do is to actually create the Bedrock knowledge base and actually point it to our data source here. And then what happens is Amazon Bedrock actually uses what's called an embedding model in AWS, which is basically an LLM that converts your input documents into chunks, and then it takes those chunks and it converts them into vector embeddings, which are ultimately stored for long-term storage and retrieval in what's called a vector database. Vector databases are kind of a new industry, kind of hot trend that we're starting to see. There's lots of different vector storage engines out there. One of them is MongoDB. There's lots of other vector storage engines, and some of them are supported by the Bedrock Knowledge Base service. We've got things like MongoDB. We've got things like Redis Enterprise Cloud. There's another vector database out there called Pinecone as well. I'll probably do a separate video on Pinecone with Bedrock knowledge bases as well. In this particular video, we're going to be focusing on MongoDB, specifically MongoDB Atlas, which is basically a managed cloud service directly from MongoDB that provides a managed database as a service. So that's one we're going to be focusing on for this particular video, because each vector database that you use has a slightly different setup process for it that you'll want to be aware of. So in any case, these documents that we have here, we upload them into Amazon S3 object storage. Then when we create that knowledge base, the Bedrock service is going to convert those documents into vector embeddings and store those or persist those into the vector database that we select. All right, so once that is done, then we have those embeddings stored in a database. And now we, as a user here, this is our person, this is you or me, we can start to issue queries or prompts against the Amazon Bedrock service, the knowledge base service in particular. And then what happens is the Bedrock service is going to go out to that vector database and it's going to try to find similar results in that vector database based on the prompt that was fed in. And that's how it ultimately provides a response back to us as the end user here. So again, you could be a car salesman, you could be working with internal company HR data, you could be, storing information about the oil and gas industry, like maintenance manuals for oil and gas drilling rigs or something of that nature. It's really up to you as far as what you want to do inside of there. So you just export your documents, make sure they're in a supported format, put them up in S3, connect your knowledge base to that S3 data source. Then it's going to write your data to your vector database, and then finally we can issue queries. It's a pretty straightforward process, but there are some gotchas you want to be familiar with. For example, if you are going to be using an external vector database, you need to actually go set up that database before you can actually create the knowledge base itself. Now, Amazon Bedrock, when you create a knowledge base, it will actually give you an option to simply use the Amazon OpenSearch service, which is basically the Amazon fork of the Elasticsearch product. And so OpenSearch has a vector database feature as well, and it'll go ahead and set up an OpenSearch instance for you if you don't already have another vector database set up. But for the sake of this video, I actually wanted to show you how to set up MongoDB specifically as a vector database for Amazon Bedrock knowledge bases, okay? So let's go ahead and actually jump in and start to take a look hands-on at how to set all of this up. So what we're going to be doing is extensively referring to the AWS documentation. Anytime that you're trying to learn about or set up or troubleshoot any issues with any AWS services, you will always want to be going out to the documentation for those services and make sure that you understand conceptually how those services are supposed to work, what the specific supported configurations are, because it's not always obvious exactly what you have to do to set things up. Sometimes you'll just run into random errors and you have to go back to the documentation and say, hey, what did I do wrong? What is the supported configuration here that I really need to be focusing on? So make sure you refer to the AWS documentation here. You can just scroll down under product guides right here and just do a search for Bedrock here. That'll take you out to the Bedrock documentation. And then under the Bedrock documentation here, we have a couple of different documents. So it keeps switching my theme to light when I don't want it to. So I apologize for that. I did report that as a bug just so that they're aware of it. But in any case, we've got the user guide, we've got the API reference, and then we've got the Bedrock Studio user guide. Bedrock Studio is kind of a preview feature that we're not going to be focusing on right now. It's pretty buggy. I've actually played around with it a little bit myself. We're just going to be focusing on the user guide right here for Bedrock. Let me switch that theme back to dark again. And then if you scroll down in the Bedrock user guide right here, let's just minimize that. You can see we've got knowledge bases for Amazon Bedrock right here. So that's the part that we really want to be focusing on. Okay, so with Bedrock knowledge bases here, there are certain regions that are supported. There's certain models that are supported as well. So you want to familiarize yourself with that. The AWS Management Console, when you go through and actually create the knowledge base, it does kind of guide you through, which models are supported. So it's not like you have to know the exact value there. You can just kind of click one of the boxes for it. There are also some prerequisites right here. So like setting up a data source. This is the Amazon S3 bucket that you're going to use to actually contain these different source files. Also, you're going to need some actual source files to start with. So we'll talk a little bit about that as well. You also want to set up your vector index using a supported vector storage engine. And they do list in this documentation here the different database engines that are supported for vector storage by Amazon Bedrock knowledge bases. So as we just mentioned a moment ago, there's OpenSearch Serverless. There's also the Amazon Aurora database engine. I believe this is the PostgreSQL engine. Amazon Aurora does also support MySQL as well as Postgres compatible databases for their engine. There's also Pinecone DB. So if we do a search on our favorite search engine here for Pinecone DB, you can see that this is a separate company that has their own vector storage engine as well. I did actually test this out. It's very easy to set up Pinecone, but we'll do that in a different video than this one, which is focused on MongoDB, Atlas, and then there's also support for Redis Enterprise Cloud. So this documentation talks about how to set up your vector storage engine in MongoDB. Also, there is a better document directly from MongoDB themselves, and this is a blog post actually called, or it's a tutorial post, I should say, called Launch a Fully Managed RAG Workflow with MongoDB Atlas and Amazon Bedrock. And it does talk about the prerequisites and the implementation steps here as far as how to set up a MongoDB engine in the MongoDB Atlas Cloud offering. And so I actually have over here in the MongoDB Atlas service, I actually spun up a cluster right here under this project. So under organizations, you have a project, and then within that project, I can create the MongoDB database clusters. And I've actually already set this one up, but we're going to go through the actual setup process on a brand new cluster as well. So you can see I've got this cluster called Trevor-Bedrock right here. I can go into my configuration here, and I can take a look at the Atlas search configuration. So let's go over to the Atlas search tab right here. They go to Atlas search for this particular data source here, and you can see that I've set up this vector index according to the documentation for the MongoDB setup, right? And so once you've gone through and actually set this stuff up, then you can go ahead and synchronize your data source, import that data into your vector storage engine, and then you can start to ask questions about it. So let's take a look at a really quick example before we actually set up a brand new knowledge base. So over here in the AWS Management Console, I'm in the Bedrock service. You can just search for that service up in AWS Unified Search right up here at the top. And then on the hamburger menu right over here on the top left side, what we can do is go down to model access. You want to make sure that you've requested access to the Titan models as well as the Anthropic models here, because those are what you can use in Bedrock to interact with knowledge bases. So just be aware of that. So then what we want to do is actually go down to orchestration here and go down to knowledge bases. And let's minimize that here. As you can see, I've already created a knowledge base here called Trevor-MongoDB. And I'm going to go ahead and resync my data source right here. I had actually made a change to it earlier that was resulting in an error. But essentially what's happening here is that this data source that's connected to this MongoDB Atlas vector database right here is being used to ingest data from Amazon S3 into our vector storage engine. And I'm still getting an error here, probably because I actually made some changes to my vector index here. So what I'm going to do really quickly here is just go to Edit Index, and I'm going to remove some custom fields that I actually added into my vector database here. Normally, my configuration for the vector index would just look like this right here. So let's go ahead and save those changes. Also, I'm going to head over to S3 really quickly. I was playing around with this feature called metadata files, and I might have had a metadata file inside of my S3 bucket here, and that's what was causing the error earlier. So I'm just going to make sure that that file is gone. So we'll open up the bucket right here, and then I'm just going to search for any metadata files. And then once I've validated that all those are gone, I'll go ahead and resync my data source. And sure enough, right down here, you can see I've got this little metadata JSON file. So I'm just going to go ahead and delete that object from my S3 bucket here. Then we'll scroll down and click on permanently delete here, drag and drop that into the box, and click on delete objects. All right, so once that object has been deleted, I'm going to come back to my Bedrock data source here, and I'm going to go ahead and just synchronize this again. We'll click on synchronize right here. And then in just a moment here, my data source should resync and hopefully be successful this time. And now on the right-hand side here under test knowledge base, I can select a model that I want to use for inference, choose on-demand throughput, apply, and now I can ask a question. So I've already got some vehicle manuals for various vehicles like Ford F-150s, Toyota Highlanders, things of that nature. And so what I'm going to do down here in the chat is say, how do I activate the windshield wipers for a 2021 Ford F-150? We'll go ahead and send that request out. And now it's going to go out to my vector database in MongoDB Atlas right down here that's running in the Atlas service, and it's going to retrieve the data for that particular answer. So right here, it says to activate the windshield wipers, locate the wiper control stalk on the right side, rotate the end of the stalk to the desired wiper speed. So as you can see, that was a really straightforward question that I gave to it, and it gave me a really straightforward response with the individual steps. So at this point, you're probably wondering, well, how did I set up this knowledge base from scratch? And that's exactly what we're going to do right now. I'm going to assume that for the sake of this demo that you already have an AWS account and that you also have access to MongoDB. Now, as of this recording, there is actually a bug in the MongoDB free tier, so don't use the free tier. You want to make sure that you use the paid tier of the MongoDB Atlas service. So make sure that you're using at least an M10 instance size or larger. That costs about 8 cents an hour. So just be aware that there is a little bit of a cost for the MongoDB service as well. However, if you're working in a company environment with billing set up already through AWS, you can actually purchase MongoDB through the marketplace in AWS. So if we go back to the AWS console here and then just search for the marketplace feature here, we can head out to the AWS marketplace, and I've already subscribed to MongoDB in here. So if I take a look at my subscriptions right here, I should see MongoDB somewhere, maybe on page number 2. So sure enough, right here is MongoDB. But if you don't already have this subscription in your AWS account, you can go to Discover Products, and then you can do a search right here in the marketplace for things like MongoDB. You can also search for PineConeDB as well as Redis Enterprise Cloud. So really quickly, if we do Redis, just to finish Redis Enterprise Cloud right here, you can see we've got the pay-as-you-go pricing here. We could also do a search for things like PineConeDB. Here's Pinecone Vector Database, pay-as-you-go pricing, or you can do an annual commit to get a discount. And then we can also do a search for MongoDB Atlas. So right here is MongoDB Atlas with the pay-as-you-go pricing model. And so then you'll have a subscribe button somewhere right down here. I forget exactly where that shows up. I think you can go over to pricing here, and then there should be a subscribe button somewhere here, but I've already subscribed to it, so I don't have that subscribe button again. And then once you are subscribed to MongoDB Atlas, there will be a little bar that shows up right here at the heading that tells you to finish setting up your organization in MongoDB. That'll actually kick you over to the MongoDB Atlas console where you can set up your MongoDB organization, and then you can start provisioning MongoDB in the console right over here. And that way, all the billing will actually be done through your AWS account through the marketplace. So that's a really nice way to get access to paid MongoDB instances if you don't want to set up billing separately with MongoDB directly. All right, so what we're going to do is start by focusing on our data source, right? So the very first thing, if you recall from this diagram right over here, that we need is we need some source data. So that's step number 1, is we need some source data. We need to make sure that it's in these file formats right down here, like PDF files are really easy to find online. You could find things like recipe PDFs. You could find vehicle owners manuals in PDF format as well. You can also just export HTML, right? So you could go to like Amazon and export a product page or things of that nature. Of course, take into account terms of service for each of those websites as well, and other types of resources that you obtain. But then what we want to do is to get that data up into S3. So that's what we're going to focus on right now. Now, I already have locally here in my /data folder on my local file system, you can see I've actually got some vehicles owners manuals. So I've got a vehicle owner's manual for a 2019 Subaru Legacy. I think it also covers the Subaru Outback here as well. You can see I've also got things for like a 2020 Ford F-150 right here. So I've got that vehicle owner's manual. It's 625 pages long. I've got a 2021 and 2023 Toyota Highlander as well. So you can see that I've got this vehicle manual for the Highlander. And I've also got some other ones. So here's one for the 2022 Honda Civic, for example, or a 2021 Nissan Altima. So these are all like 600 pages long or something like that. These are huge manuals. They're multiple megabytes in size. The largest one here is about 30 megs for the 2021 Toyota Highlander. So what I want to do is basically get these files up into an S3 bucket, and I can also go online and search for more. So maybe I do a search for PDF owner manual for a 2022 Honda Pilot, right? I don't have one of those yet, but here is a PDF link right here, the second link. So I'm just going to do right click save as, and I'm going to say save. It's already got an appropriate file name for it, 2022 Pilot Honda. And so if we open this up here, it's 36 megabytes and that's 737 pages. So these are huge files, right? So now what I want to do is go over to the Amazon S3 service once again, and we want to create a brand new S3 bucket, right? So we're going to go to S3 here. We're going to say create a new bucket, and I'm going to create this in the same region as where I'm going to be working with Bedrock. So I'm going to be working with Bedrock in the US West 2 Oregon region. And so what I'm going to do is just say bucket name, say Trevor Bedrock-USW2. I'll actually call this SG Trevor just to be safe there. And then down here, we're just going to say create this bucket. And then once we've created this bucket, we can go ahead and upload data into that bucket. So let's search for Bedrock here. I'm going to open up my SG Trevor Bedrock USW2 bucket here. Then I can click on this upload button right behind my head here. And then I can go ahead and just drag and drop some of these files into that location. So I could just take all these files and drag and drop them there. Also, I could use a tool like CyberDuck or tag spaces. So let me fire up CyberDuck really quickly here, and we'll take a look at how to connect that to my Amazon S3 bucket. So let me bring CyberDuck over onto this screen here, and what I could do to get this connection. So I'm already connected to my S3 location, but what I can do is head over to the Identity and Access Management service here, and I can create an IAM user with some static credentials so that I can connect CyberDuck. So I'll create an IAM user right here. I'll just call this SG Bedrock test delete me, and then we'll go ahead and say next. And then what I'm going to do is say attach policies, and I'm going to attach the S3 full access policy so I can do anything in S3 that I need to. Then we'll go ahead and create that user, go to the user details, go down to security credentials and say create an access key. We'll just do other, next, create access key. And then I'll go ahead and copy these values, go to open connection. And then for the data source here, we're going to choose the Amazon S3. And then we're just going to copy and paste the AWS access key ID and the secret access key. And then we'll say connect. And then I can go ahead and find my S3 bucket in this list here. So it's called SG Trevor, I think. So let's go ahead and find that one right here. I'll go ahead and double click on that to open up that S3 bucket. And then I can open up the Windows Explorer here, and we'll go ahead and copy and paste these files into that S3 bucket. So now I've got this little transfer window. You can see this data is currently uploading right here. And after this data is finished uploading, we can go ahead and then create our vector database. And so we'll go ahead and do that while this data is uploading. Okay, so now we'll hit continue here. We'll go ahead and close this IAM window because we don't need that any longer. Go back to S3 here. We don't really need our S3 window here any longer either. So we're going to just go back to the Bedrock service. And then what we're going to do is actually take a look at the process of creating a knowledge base here so you can see where we would get stuck if we don't have a vector database. So let's click on create knowledge base. And then for starters, we can just do a knowledge base name. So let's do Trevor-YouTube here. And then I'm just going to use the default IAM permissions. So it'll create a new role in IAM with the necessary permissions. I'm going to add a tag here just so that my teammates know that I created this. So we'll do next down here. The next thing is going to be the data source, right? So the data source, I can just give it a name like my S3 data, and then it's going to be in this AWS account. And we need to specify an S3 URI. We can actually have multiple data sources, so you can have maximum of 5 S3 data sources, but in this case, we're just going to have a single S3 bucket. So we'll go to Browse, we'll search for Bedrock here, and we'll choose this S3 bucket that I just created here. So we'll go ahead and click on choose. We don't have a KMS key for encryption, so we don't need to go ahead and add that. So we'll do next. And now this is where we choose our embeddings model. And I typically use the Titan embeddings model right here. So we'll go ahead and choose that one. And now we are prompted for a vector database. So the default option that we have here is to quick create an Amazon OpenSearch serverless instance. But the other option that we have is to choose a vector store that we've already created. And if we choose that option, you can see the 5 different options that we have available for a vector database. So we have OpenSearch serverless, we have Amazon Aurora, Postgres compatibility, not MySQL. We have MongoDB Atlas, which is the one we're going to be using. We have Pinecone, and it looks like they're missing the icon for it there for some odd reason. It's just not loading in. And then finally, we have Redis Enterprise Cloud here. So we're going to be choosing MongoDB Atlas, but when we choose one of these external options like Pinecone or MongoDB Atlas or Redis Enterprise Cloud, we have to actually tell the Bedrock service how to connect to that remote database engine, right? So we actually have to go create the database first, then we have to create a user for authentication, we have to make sure that the network access is open for it as well, and then we also actually have to create an AWS Secrets Manager secret. That's actually something that I forgot on this diagram over here. If we're using an external database engine like that, we need to create a secret in AWS Secrets Manager here. Let's see, where's that icon getting created? Oh, I need to open up editing on this right here. So we'll open up Secrets Manager here. And Secrets Manager actually needs to connect over to the Bedrock service. So this would connect kind of right up here. And what we need to do is create a secret in Secrets Manager that contains the credential from the external provider like MongoDB or Pinecone or what have you. So this is how we feed the credentials for the database engine into Bedrock, is by creating a secret in Secrets Manager. So let's go ahead and take a look at how to actually set up the vector database, right? So I'm going to come over to the MongoDB Atlas right here, and let's just really quickly check on our S3 transfer here. Looks like it's still going here. I'm on Starlink internet, so the upload speed leaves a lot to be desired. But what we're going to do is create a brand new cluster. So I'm going to go into the project right here, and we're going to say, go into the Trevor project in MongoDB Atlas. Then we're going to create a new cluster in here. And again, we're going to be following this guide right here. There is also MongoDB documentation for knowledge bases as well. If we just do a quick search for that, I think it might be this documentation here. Yep, I'm pretty sure that this is it. So this talks about how to get started with Bedrock knowledge bases, talks about how to set up everything here. So this is a really helpful document as well. So what we're going to do is say, go to clusters, then we're going to create the cluster, then we're going to create a collection in the cluster. We're going to define the Atlas vector search index, which we use this JSON configuration down here for, and then we can connect it over to Bedrock. So I'll click on Create Cluster, and I'm going to create an M10 cluster, because remember that there is a bug in the free tier. So I'm going to choose the dedicated option. I'm going to put it in AWS, because you do have the option to use Google Cloud or Microsoft Azure for their deployment models as well. I'm going to choose the US West 2 Oregon region, because that's where I'm going to be creating my Bedrock instance as well. For the cluster tier here, I don't need M30. M30 is kind of expensive at 54 cents an hour. So I'm just going to choose the M10 instance right here. And then I think that's pretty much all we need to specify here. You also can choose an engine version, but I'm also going to just leave that at the default here. So I'm going to turn off the cloud backup because I don't think I need that. And then finally, we can just click on Create a Cluster here. Now, the cluster will take a few minutes to deploy, so be patient with that. As you can see, it's going to deploy 3 different servers for high availability. And so we're just going to give that a chance to deploy. All right, so we've got cluster 0 right down here. And then what we need to do is actually set up network access for that cluster. So we want to make sure that network access is allowed from anywhere so that the Bedrock service is able to access our server. And then we also need to create a user in order to access the database. So to create the user, we'll come up to database access right here. You can say add new database user right here. I'll call this Trevor-Bedrock Bedrock as the username. And for the password, I'll do Trevor-Bedrock999. And then we'll say that it has user privileges to pretty much everything inside of this project right here. So we'll say add a built-in role and say that it has read and write access to any database. And then we'll click on add user. So while that database cluster is being created, we'll come up to overview here and just keep an eye on it here. And then what we're going to do is actually plug our username and password into the Secrets Manager service. So again, the Secrets Manager service is how we feed the credentials for our external vector database that's running in the external MongoDB service into the Bedrock service. So we'll come back to the AWS console right here and open up the Secrets Manager service right here. We'll open that up in a new tab. We'll say store a new secret. We'll say other type of secret. And then we need to set a couple of key value pairs. So we want username, and this will be Trevor-Bedrock. And then we're going to add a password key, and this will be Trevor-Bedrock999. And then we can go ahead and just click on next right down here, and we'll just give it a name like Trevor Bedrock /YouTube. And then I'll add a tag here so that my teammates know who created this, just in case we need to clean that up in the future. And then we'll just say next, next, and then store. Okay, so now we've got this new secret. So we'll just do a refresh here, go into that secret, and we want to copy the secret Amazon resource name, or ARN. So the ARN is what we need to feed back into the knowledge base configuration in order to configure it. So right down here under credentials secret ARN, we'll go ahead and paste that in. Then for the host name here, we need the host name, the database name, the collection name, and these fields right down here for metadata field mapping. And these are going to come from the MongoDB instance itself. So right over here in the MongoDB console, we're going to wait for this to finish deploying, and then we can go ahead and connect to the database cluster and actually get its unique DNS name. And we'll do the other setup and configuration in the Atlas search section right down here once this cluster becomes available. So let's give this a second to become available, and we'll come right back. Okay, so our cluster has finished deploying now. So what we need to do is to follow the directions in the documentation here to create a database and collection in that database. Then we need to define the Atlas vector search index for Amazon Bedrock and plug all those details into the Bedrock service. So what we want to do is come over to our cluster here. We want to go ahead and open up the collections. So let's do the database here and then go under, I think it's browse collections. So we'll say add data here, and then we'll say create data. Somewhere here is a create option for the collections themselves. Let's see if we can find that under the database option here. Let's actually just refer to the documentation. So it says go to the clusters view and click on browse collections. So here's our database. We'll go to browse collections, and then there should be an option to create a new collection. So say add your first database. We'll call this bedrock_db, and then just call the collection bedrock and click on create. Now that we've got that collection created, you can use whatever names you want for the database and the collection name, by the way. But for the Atlas Vector Search Index, we need to head over to the Atlas Vector Search section. So we're going to go over to Atlas Search here on the left-hand side, choose cluster 0, and say go to Atlas Search. And then we're going to enter the name for the index called vector_index. So we'll say create a search index. We want to go to the JSON editor here and then click on the next button, plug in vector_index for that index name. And then we want to choose the JSON right here and go ahead and just paste that in to the vector configuration, and then open up the database and then select the Bedrock collection here. And if you get this JSON validation issue right here, you actually want to go back and choose Atlas Vector Search JSON Editor. I just chose the wrong one right there. Go ahead and paste in that JSON, choose the collection right here, and then click on Next, and then create search index. Now, once the search index has been created, we can come back over to the Bedrock console and finish setting things up. So for the database name, we're going to say Bedrock underscore DB. For the collection name, we're just going to plug in Bedrock. And then down here for the vector search index name, we're just going to paste in vector underscore index. And then based on the JSON, we have the embedding path. So that'll just be embedding. And then we have metadata and then text chunk. So let's go ahead and plug in those values here. So for text, it'll be text chunk. For the vector embedding field path, it'll just be embedding. And then for the metadata field path, it'll just be metadata. So these need to correspond to the paths that you have in this JSON configuration. And then the last thing that we need to specify here is going to be the host name of the MongoDB cluster itself. And this is really easy to find over in the MongoDB Atlas console here. So we'll go back to the MongoDB Atlas console. We'll go down to our cluster 0 database right here and then click on this connect button. And then when it pops up with this window here, we'll just open up shell here. And then you can see right down here is the DNS name of our cluster. So we'll go ahead and just paste that in right here. And then we'll hit next. And finally, we'll just click on the create knowledge base button here, and that will go ahead and invoke creation of this new knowledge base. It'll connect to our MongoDB Atlas database. It'll connect to our S3 data source, which is this bucket that we just created. And let's actually check on our upload status. It looks like our upload of all of our vehicle manuals here has finished. So it should be able to ingest that data. So let's give this a chance to create the IAM role for knowledge base, connect to the S3 bucket, and then generate those embeddings. As you can see right down here, our data source is available. So we can just choose that data source and then say sync, and that will synchronize all of the data from our S3 data source over into our MongoDB cluster. And then once that is finished, we should be able to query that data from our vector database. And while this says status in progress, we won't be able to run a sync here. So just wait for this to be finished or active or whatever it is. And then after that shows as active, then you can come down here and hit sync on your data source. So I'm just going to come back up to my knowledge base's parent page right here and keep an eye on the status field of my knowledge base down here until it says ready. As you can see, it only took a few moments here for that knowledge base to become ready. So I'm going to drill into that knowledge base right here and close off that side tab. And now right down here under my S3 data, I'm just going to check off the sync option right here. And that will cause the embeddings model here to chunk the text, generate the vector embeddings, and then write those vector embeddings into the MongoDB database. So we could actually monitor our database right over here and actually take a look at the disk utilization here and the number of connections and actually see that this disk utilization is going to go up once we actually have those vector embeddings stored in the vector database. So I'm going to give this a couple of minutes to generate those embeddings, and then we'll come right back and actually test it out. All right, so it looks like our data source has finished synchronizing. As you can see, our data source is now showing as available inside of our Bedrock knowledge base here. So that's a good indication that everything is good to go. So if we come over to our cluster metrics right here, you can see that our storage has actually grown from like 1.5 gigs up to 1.9 gigs. And you can also see that our read and write capacity and our bandwidth in and out has actually increased quite a bit here as well. And so that's a good indication from the monitoring or observability data that our vector index is actually being accessed by the Bedrock service here. So now the last thing for us to do is actually to test out our Bedrock knowledge base and make sure that it's actually working. So what we'll do is come back over here and click test on our knowledge base here, and then we'll select a model for inference, like Claude 3 Sonnet is probably my favorite. And then we'll go ahead and enter a prompt, like what tire sizes can I use for a Honda Civic? I'll also plug in 2022 here because I think that's the only year that we have a manual for, and we'll see what kind of response we get back. And it looks like that isn't being supported right now. It looks like it doesn't have answers to that. So maybe I'll try something else like, does the Honda Civic have lane assist features? And let's go ahead and run that. And as you can see, we got back a really useful response here. It says that the 2022 Honda Civic does come equipped with these features right down here, like lane keeping assist. So then we can say, does the Honda Pilot support lane assist? And let's run that query as well. And it looks like the Honda Pilot also has lane keeping assistance. So as you can see, we're able to just ask really basic questions about different vehicles, like how do I activate high beams on the Subaru Legacy? Okay, let's try that as well. Just see if we can try a couple of different documents here that we're retrieving from our knowledge base. And as you can see, it tells us exactly how to activate high beams on a Subaru Legacy. So now that we've gone through the entire setup process of setting up our vector storage engine, let's just switch back to this diagram. We set up our vector storage engine, we set up our S3 bucket, we grabbed some source files from the internet, and we uploaded those supported file formats up into our S3 bucket. Then we created our AWS Secrets Manager secret to store the username and password for our vector storage engine right over here. And then finally, we created that Bedrock knowledge base. We connected it to our S3 data source and to our MongoDB vector storage engine. And then the Bedrock knowledge base is now something that we can query directly and get responses from those documents. At this point, we can actually iterate on this process by simply adding new documents into our S3 bucket, and then we can go over to the Bedrock knowledge base and click on our data source here and just say sync, and that will update our MongoDB vector database with the latest embeddings from the documents that we have in our S3 bucket. So you can continuously iterate on the data source there, import new data, and always have the latest up-to-date information in your vector database. That's part of the value that the Bedrock service brings to the table here. Now, I did also want to mention that while it's cool to be able to test this through the AWS Management Console, what you really want to do is probably integrate this into your application, right? And so if you're building an application, you can actually use a couple of different APIs. So if you go to the Bedrock API reference and go under agents for Amazon Bedrock Runtime here and take a look at retrieve as well as retrieve and generate, these are the two API calls that you're going to want to take a look at in order to incorporate a prompt and a response into your application. Now, as you can see, these are relatively complex APIs here, so we'll probably have to do a separate video that talks about how to actually do this type of integration here, but these are the two different APIs that you want to take a look at. The retrieve and generate here is going to give you kind of a plain English type of response like what we had right here, whereas if you use the retrieve API, what that's going to do is it'll retrieve data from the vector database and it'll reference it, but it's not going to give you that kind of plain English readable type of response. It'll just give you kind of the raw data sources that you have. As you can see right here, we can actually just retrieve the data by just disabling generate responses, and that'll just give us references to data rather than actually generating the entire plain English response. So that's what those two different APIs are for, retrieve and generate. Also, there is a feature, if you don't want to go through this whole process and you just want to test out chatting with a document, you can actually go back to the knowledge bases feature and you'll see this tab right here that says chat with your document. And what you can do is select a model like Claude 3 Sonnet here. You can upload a document from your computer locally here, like a PDF file up to 10 megabytes. So you are a little bit limited there. And then you can actually chat with that document right here in the console without going through the entire setup process as well. So if you just want to play around with the feature and you're not actually looking to set up your own internal knowledge base, then feel free to use the chat with your document feature here. So in any case, I hope that this video has been useful for you. We talked about the entire architecture of the Amazon Bedrock knowledge bases, how to set up a vector database engine with MongoDB, Atlas, how to set up your data source with Amazon S3, how to import your credentials for your vector storage engine into Amazon Bedrock, and then finally, create and test the knowledge base with the Bedrock service. So I hope that you've learned something new from this video. I would encourage you to go out and play around with this feature yourself. Grab your own source data set with some PDF files or some Word documents or Excel documents or something like that. Import those into your knowledge base and then test out this knowledge base feature because it's really cool how it allows you to interact with raw document files. Thanks so much for watching this video, and we'll see you in the next video. Make sure that you like this video, subscribe, and leave a comment and let us know what you thought of this video. Thanks again for watching, and we'll see you soon.